Okay. Oops. Sorry. Okay. So welcome everybody to FM+SE Summit Tokyo 2024. So on behalf of Jack, Yasu, welcome to coming here, and we're going to start now. So probably this is the most important slide today because it has the Wi-Fi password. Okay. So please make sure you take a note of that. The program is printed on your web. There's a print of the program on your desk. Okay. But as well, please check because there's some small updates online. Okay. So you guys can go sit down. Okay. Okay. Thank you. So what I'm going to be doing today is going to kind of introduce this FM+SE kind of area that we've been working on for the last few years, kind of put a bigger context of where we're going, and then from there we're going to start the session and try to kind of get us all working together in this area. Okay. So we talk a lot about this idea of foundational models. When we talk about foundational models, think of them the same thing as a lot of people say LLMs, large language models. Now, the reason we don't like to use the words large language models is because we recognize that it's not only going to be about language, it's going to be about video, about pictures, it's going to be multimodal, and it's not even going to be about large. Okay, so Sam Altman, last year made it very clear that it's not a game of bigger and bigger. Okay, we already have seen, these models already coming. Google Gemini models actually already fitting on a phone. Okay, IBM. AWS, everybody recognize the size is not really the issue, but it's actually the foundational aspect of that. So you're going to see us today a lot talk about this idea of AIware. So what is AIware? So we went from this idea from codeware at the beginning, so that's just software system made out of code. From there we moved to neuralware, which is neural network kind of type of software. This has been kind of what we've been doing for the last maybe 5-10 years. Now we've seen this big jump with the GPT and the large language models and the foundational models with promptware. And as of the last 6 months, the really big thing that's coming up now is agentware. And beyond that is mindware. The key part out of all of this is we're really moving from software that's developed by a small number of people that are experts into a world where billions of users from around the world, independent of their age, independent of actually their background, their training, should be able to develop software. So it's really, while a lot of people think of this as the end of software engineers, actually, in our opinion, this is really the beginning of making software more democratized and having more and more people working on software systems. So when you think about it, so how is foundational models and software engineering interconnected? So there are really different ways you can think about it. So there's foundational model for software engineering. So this is kind of using FMware for SE kind of topics, SE challenges, whether generating code, fixing bugs. So this is more like intelligent software 2.0. The other thing as well, the other side of it is SE for FM or AI-powered software. So this, in this case, this is like AI engineering 2.0. But today as well, we started to recognize that these type of foundational models, the software is one of the most complex software that we're building today. So things like GPT, the Pangu model, the Gemini models, all these models are very complex software systems that require an enormous amount of distributed systems to work on. And even just one small bug will lead to millions of dollars of problems as you try to fix these bugs. And within there as well, even the software engineering for neural network kind of operators. But as well, we see that even totally changing, not just even software engineering, but how we teach software. What does it really mean to even get a degree in software engineering moving forward? And even how we do software research itself, whether they can assist us. So as you can see, there's 5 big dimensions here, and today we're going to see different people talking about different aspects of this from around that whole spectrum. So we do have 2 days, so there's a lot of things that we're going to be trying to talk about today. But one thing that's very clear is the way we make software is totally changing. And actually even the definition of what is software as well is changing. Okay? We're going to these systems that will read the developer's mind, and immediately as you pull your hand down, you get the right tool to do the job. They're able to actually work with you and collaborate with you as truly AI teammates. So not just as a co-pilot, but in many ways, 2 partners working with you. And that's what we're going to be seeing today. We have a lot of experts from around the world coming in today to talk about that vision and to share what they're working on. So in particular, I want to spend a little bit of time to tell you some of our visions of what we're seeing, and some of these themes are going to be iterated throughout the day today as well and tomorrow as well. The reality is we believe that foundational models change everything. And we have just started as well a new conference called AIwareConf.org, okay, that is really working on trying to redefine what exactly is software engineering in that new world. Now, there are many things we need to think about here today. So we're really thinking how we can go beyond ChatGPT, okay? So we're really thinking of these intelligent and controlled agents. So at the beginning, you know, a lot of people were excited with this idea of, you know, you're chatting with GPT and you say, make my essay more professional. Then we got into GitHub, which is write a function to sort a link for, a linked list for me, okay, a list. Then we moved on, and this is where it really got excited and really where we recognize it's totally going to change how we develop software, where there is no code anymore. You know, the foundational model is the code. It is actually operating and computing what you want. So you tell it, you now just, I don't want to see code. I just want you to sort, you know, that array for me, okay? And then beyond that, we're already seeing some early signs of this, which is the whole program as a foundational model. So in this case, this is where this idea of this FMware and agentware, there's actually very little code there. It's all the foundational model kind of operating. It's almost like a new type of compute unit. Okay. The other thing as well we're seeing is going beyond professional developers. Okay. People of all ages and all backgrounds should be able to code, and we call that really this idea of software makers. Okay. And you know, what we're seeing as well is this whole revolution. So today there's a big excitement about text-based foundational models, language-based foundational models, but we know that just 2 years, 3 years behind, we're actually already seeing there's already a big push on visual type of models. So being in a meeting, a developer meeting, you know, pulling up stuff from the whiteboard, all that type of information can actually be pushed back in to help with the design of software. I don't need to write anything. I could just draw my software and it will actually become a reality. Okay. One of the most interesting things, and this is really what you will notice about today, the people we brought here, is that we have really moved from, especially in this area where it was, a lot of it was only done in research labs, where instead we're seeing industry, open source, and as well academia working together, and more that mixture of all of them producing this new thing. So for example, some of the most popular large language models for source code, like the Star Coder, is based on a consortium of many industry partners, many academics, many research labs, and open source volunteers working together to produce this. So it's a very different way of actually collaborating than we used to, beyond even this concept of open source. Now, the reality is, at the end of the day, trust and safety is very important. And there are really two things that we're going to see here. If let's go all the way back when cars were created. When first cars were created, one of the concerns were that they go too fast. So the first rules were any car will have to have a person walking in front of the car with a red flag, ensuring that the car cannot go faster than a human. Today we don't see any humans running in front of cars, so that didn't really work out. Then we moved on to, to actually having, seat belts. But it took, 30 plus years to get seat belts right and to get them into legislations. So the reality is, yes, trust is important. It will take time. But in addition to that, we need to work together to actually make sure that these systems are trusted and safe. Now, this comments and what I'm sharing here is not just my view, but it's the view of many of the leaders as well in the area. So, for example, Benji's really emphasized that around last year, where he really recognized that the power of these systems and their capabilities is something that he never really imagined when he started in that area. Now, we need to be realistic as well, and this is one of the biggest areas where software engineering will play a big role, is that these systems are not that good. They're improving, but in reality, they have a lot of challenges, as you can see from comments from Jan LeCun. And from Sal Khan from Khan Academy, he's really emphasizing that, yes, there is a lot of bad things that can happen, but there's a lot of good. And if we're always going to be concerned about the bad, we cannot actually stop the evolution. We really need to join it and shape it where it's going to be going. I like to use this code. So this is a document that Bill Gates sent to his team, around, how many years ago? 1995, so, yeah, what was that, 30 years ago? Okay, so at that time, Bill Gates discovered the internet, and he sent to everybody in his org saying the internet is going to change everything. Well, it's the same thing here. So if you really want, you can just replace internet here with foundational models, and that's exactly the way we feel about it. Okay? Now, a lot of the excitement comes in not from just using these foundational models raw, but actually fine-tuning them, being used by experts that really know how to pull the best out of them. And this is the part where software engineering will play the biggest role. Okay? So the best way I like to summarize this is this picture. If you don't know, if you put a frog in a jar and you start boiling the jar, the frog will stay in that jar till they die. They will just boil and get cooked, right? So what we're seeing today is a lot of people in the industry, do you see it happening? They see the foundational model revolution happening, but they don't recognize how it will impact them, or they feel it's not going to impact them soon. Okay? So today, the fact you're sitting here, so you're outside of this, boiling jar. So please, I do encourage you when you go back home, try to save one or two of your friends and pull them out of the jar, okay? So that's your mission, okay? At least have 2 people you saved, telling them about what's happening in the world. Now, I'm going to structure this presentation on 3 areas. So how are they going to change business, how are they going to change software, and how are they actually going to change the compute fabric itself. When it comes to business, the reality is that foundational models will not replace humans, but there's one thing we know for sure, that humans that are not using foundational models will be replaced by humans that are using them. Okay. And then when you actually talk about, software itself, the definition of what software is totally changing. This idea of AIware, software that does not have any source code in it. And then finally, this idea of compute. We have gone from this idea where you can have a couple of 1 or 2 very powerful machines to really be a big player in this domain. You really need to have a full cluster of compute. And how to actually use these clusters, and these clusters are the base of accelerators, it's a whole different world. And in particular, a very interesting thing, we believe that there is the beginning of this the end of this dominance of the GPU and other types of technologies and other types of accelerator, whereas NPU, TPU, and so on. Okay? So I'm talking briefly about the business aspect. So as we know, in last year, Gartner declared, this idea of AI augmented software engineering and as well, foundational models to be at the top of the hype cycle. So this is already, there's a very big understanding of the industry that there's a lot of changes happening and there's a lot of potential, but how can we make that potential a reality? Now, when you even talk about some of the big leaders, so, the question is, how is that going to change your business? Well, I guess the one thing you don't have to worry about, at least something that will make you less worried, is that even Bill Gates is trying to figure this out, okay? Today, we know some things that they're very good at. We know some things that they're very bad at. But we're still having a much deeper discussion that needs to be done about what are they good for and how we can make them better on specific use cases. Now, foundational models are not new. They've been around for many years. But what is really why this is so exciting? So 2 things. As we started building larger and larger models, we started to have these emergence of capabilities, things that we didn't think they could do, their ability to actually reason. So that's one. The other thing which was really amazing, especially, so there was this work done by a Microsoft research on the sparks of AI or sparks of intelligence, where they actually recognize that these foundational models are very fast at learning. So imagine having a very fast person that can immediately, you show them something very small, they can pick it up and they can learn and they can start automating this. So their ability to learn very fast, their ability to reasoning is really where the promise comes down. Now, when you look at actually throughout the industry itself, so Sequoia, one of the largest venture capitalists in the Valley, is really realizing that this is a very big area. And this idea of AI teammates is a big area that they would like to invest in quite heavily in the next few years. And usually Sequoia does not put a public call for actually startups, but for this case, they actually said, if you have any ideas along this domain, please reach out to us. Okay. Now, when we see of these teammates, there are many challenges that can happen around them. So first is how to effectively communicate with these teammates. thinking of legal issues, trustworthiness, and as well as the efficiency. So now today when you talk with another human, we have optimized how we talk. There's a lot of things I don't have to tell you. For example, if I tell you write a piece of code, I don't have to tell you, please make sure that that code doesn't have any bugs in it. Whereas these foundational models, what we know today is reminding them that actually you want code that doesn't have bugs improves their quality considerably. So something as simple as that. So the same way, as if you think about it, we landed on a new planet, there's these new aliens, and how we want to communicate with them is a very important thing. The other thing is how to raise them. So we want, and it takes really a village to raise that, and for the first time, I really think as educators, we need to ask ourselves as well as how we can teach them the way we teach students, to become better coders or become better software developers, okay? Now, it's going to change as well. We know today from all our work in software engineering that software engineering is a collaborative effort. It's a team effort. You build relations with people. How do you actually build relations with these teammates? Very different. You probably will not. But at the same time, especially when it comes to junior developers, it drops a lot of the worries they have about talking about a senior developer. So imagine every now junior developer has a mentor 24/7 available for them. And then how to deploy them and their end-to-end value. So there's a lot of excitement about them producing code, but the reality is, yes, if they speed up the coding process, but then we end up with a lot of bugs later, their end-to-end value is actually worse than not having them. Okay? What we believe today is that we need to think beyond augmenting software engineering by actually transforming software engineering. Today, there's a lot of places where AI is being used just because of either we don't think, today we believe that it's very hard for our human brains to actually think about design, coding, and testing. So we actually broke them into different things, and then we try to automate all of them separately. But why do you need to do that if you have something that's so smart that can do all of that together? Okay? So these kind of silos, these breakdowns we have don't make a lot of sense. And to give you a very concrete example, so Tesla a few years ago, they reworked their whole driving stack. So originally, they were thinking of codeware. So in a codeware setting, you're limited by the intelligence of a human about the complexity of software that they can write. So you can see here, this is as much, as they can do as a human. So this is the limits of our complexity as humans. But now, when we actually have AI that's trying to write the code instead, and we just give it the parameters, the requirements we have, and we're letting it search, there's a very good chance it can actually find much more complex programs. And these much more complex programs can solve much more complex problems. We've seen this with Tesla, we've seen this with AlphaGo, we've seen it with DevGo. So really, how to rethink software engineering with that in mind. Now, a couple of things you need to realize is a lot of times today, the idea is, well, one thing we know at least is at the very lowest level, replacing or reducing the number of developers that are working, we believe in the next few years, maybe that could be reduced. But you have to recognize that if you today reduce the number of developers at the bottom, and now you're producing code at 3 or 4 times faster, then you need to adjust the whole pipeline, right? Because if you're producing code 3 times as faster, but it didn't speed up how you're doing code reviewing, you didn't speed up how you're doing code testing, that speed up will just bottleneck you out, right? Second is, today's customers' expectations are much, much higher, and they're only getting higher as they interact with these systems. Today, nobody, a few years ago, 4 years ago, nobody expected that you should be able to talk to their web browser and the web browser can read their mind and do everything for them. And more of that expectations are becoming more and more important. Okay? So, the idea here today is it's very important when you're thinking of this is not only to think of the foundation model by itself, but as well, thinking of it as your data and your own business sense. So for me, for example, I'm a software engineer. It's very important to me really have a deep understanding of what it means to do software engineering, what it means to develop software. To recognize, for example, that at the end of the day, code was never the end. Software was never about code. Software was about delivering value to the customer, and code was just a middle thing to do that. Okay? So the sole excitement about just producing code is not really the right approach, right? And this is something as well, not only myself is saying that, but as well, Dario Gil, the president of IBM Research, really highlighting to all the IBM customers, it's not just about the foundational model, because if everybody in the world is going to use GPT-4 or 5, 8, or 10, then what is going to be your competitive advantage? What's so special about you? So this is really the beginning of really emphasizing and recognizing what makes your development, your development organization more efficient, what makes your products more unique. Okay. So now I want to talk about software. So as I said, we already talked about how we have moved from just generating an essay all the way to you are the compiler, you are the web browser. There are a lot of challenges about that, right? So whether it's the complexity of the tasks themselves that we're working on, the hallucinations, so we know they hallucinate, they're not able to use a lot of the external tools, there's a lot of context limitations, they cannot learn over time, so there's a lot of problems there. And whereas a lot of AI folks get very excited about emerging capabilities, we in software engineering actually get very excited about emerging limitations. So we're starting to recognize that there are things that they're not good at. And now the question is, maybe either we don't ask them to do these things, okay, or we figure out how to make them better. For example, when it comes to generation of images, foundational models are very bad at generating people's hands. Okay? They don't know that we have actually 5 fingers, and they don't know that our fingers stick up, they don't go sideways. Okay? So when we look at like Sam Altman as well, the key issue right now today is everybody, even in the AI community, recognize that the technology is not fully ready, but we cannot keep that and then suddenly, once it's ready, put it out to the world. It's a learning process back and forth. So on one extreme, we have the AI folks, which have really very focused on high innovation, but the reality today, software is very critical to our infrastructure and our daily life. And getting that middle between the excitement of the AI folks and the rigor and the engineering of software engineering is really a very important thing as we move forward. Now, foundational models, the best way to think about them is they are really programming's calculator moment. When we created calculators, we did not fire all the professors that are teaching math in universities, right? We didn't stop teaching kids maths. When we created Excel, we didn't fire all the accountants. Instead, what ended up happening is the accountants, the mathematician, can now focus on the more challenging, the more interesting things, and everybody else can do their own stuff. You end up doing your taxes, and then when you need something challenging, you call an accountant. Okay? So we're moving now from millions of developers to billions of software makers. We're now having developers that are more happy. They're working on things that are more exciting, not just doing very boring, for example, UI testing or UI creation. And as well, even the ones that are doing interesting stuff, they're becoming extremely more productive. So there's a big thing in software engineering has been this idea of the 10x developer. Anybody that works in a company, there are developers that are 10x or even 50x more efficient than other ones. Can we make all our developers at that? And this, so the very summary of here is, as we said, so we went from software 1, which is codeware, based on code, developers are driving it, to neuralware. Instead of writing code, you actually define a neural network, parameters, and then you start searching for the program. Then to promptware, which is what you're seeing a lot today, which is you just prompting a foundational model to make it create the software for you. To agents, where now we're seeing the shift where it's more human and AI working together, all the way to software 5.0, which is more, there's more this, this kind of general intelligence happening here, where actually we'll be moving from AI co-pilots to human being the co-pilot, and the AI is the one driving. Now, is this crazy stuff we're talking about? No, it's not. And to give you a very concrete example, so in the old days, a lot of the cars to do this automatic wiper was rain sensor, so as soon as it rains, the car wiper would start working. You had to do a lot of code and a lot of actually physics to have these special sensors, and based on the sensor, you would actually operate the wipers. But we moved to that where today we're recognizing that, with AIware, You don't need to do that. You can take 1,000 pictures of a windshield wiper with rain on it, and 1,000 pictures of windshield wiper with no rain on it, and then every millisecond, you're taking a picture as your car is driving. And then you're feeding it for a model, and then the model is deciding whether this is a rain picture or not a rain picture. And if it's a rain picture, it starts swiping. Now imagine now you're driving and the sun is hitting your windshield, and the model gets confused and it thinks it's raining. So instead of actually writing code to fix this, all you need to do, you take a picture, and then you say, this is a picture of no rain, even though there's a sun, and suddenly we fix a bug. So we're fixing bugs using data and without developers in the middle of the loop, right? Now, this idea of this data-oriented programming, data-driven programming, is something as well that Andrew Ng had proposed many years ago. And it has been driving a lot of the innovation in AI, but the biggest problem was data tagging was extremely expensive. Okay? So what ended up happening, it was only happening in the the industries where there's a lot of money, the very big industries. So, for example, in ads, in web search, but for automated manufacturing, for example, inspecting pills, inspecting some hardware production line, a lot of that data was not being tagged. It was too expensive. But with foundational models, and we're already seeing that throughout the industry, where a lot of people are using GPT-4 to do their data tagging to really speed them up. Okay, so this is kind of the beginning where we're moving from coding to actually alignment and programming using alignment of data. Okay. So today, when you look at AIware, we are, we can think of it as 3 phases. So there's end user programming, enterprise programming, and system programming. So in end user programming, this is things like just you chatting with GPT to fix your essay. Okay. In enterprise programming, we're starting already to see that Microsoft already has a lot of work in there, especially their Power Automate. Even Microsoft Flash Fill was, I would say, one of the early signs of that, right? So in enterprise programming. And then in system programming, which we're already seeing some early signs of this, where people are trying to replace databases and operating systems by a foundational model in the core of it. So moving forward, when it comes to this future AIware, we see 4 big directions. First, they're going to be hyper accessible. Okay? So by hyper accessibility, billions of software makers can actually work on this. Okay? So it's not 1 or 2 or 100 or a million software, maybe 100,000 or maybe there's a million developers out in the world, but there are billions of people today that can actually go up and start working on that. And then software will continuously improve. This is a big difference of how we think of software. Today, you think of your piece of software, once you have it, unless your company, the company that produces actually sends you a new update, that software does not improve by itself. It doesn't adjust over time. It doesn't adjust to your own liking. That's going to be changing. As well, in addition to that is, we're going to be talking where there's a lot of conversation going back and forth with software. It's very similar when you have a new intern, a new person that joined the company. The first time you ask them to do something, they don't do it so good. The second time, they get better. By the third time, they're really great. And if they don't improve, you're going to fire them. So the same thing, if the software is not going to get better, you're going to fire it. You're going to actually, get a new piece of software. That way of evolving with the software is a very different way than we used to, okay? Now, trustworthiness is going to be built in. That's essential. But today, the way trustworthiness is built in, it's actually not built in. It's done as a patch. It's just guardrails that are put outside to protect. Instead, it really needs to be at the core using, what we call, these constitutions. So if you look at the graph at the bottom, so the human impact and human involvement is going to start dropping and dropping, and the AI involvement will start increasing. However, one thing to be clear, even at Software 5.0, human will still play a very important role in the decisions. Okay? And the best way to think about it, the human today will be the co-pilot, the expert, the supervisor. So the AI is driving, and then when it gets confused, unless it had already had a decision from you that I've seen before, it will say, hey, human, I need your help on here, help me. But then next time, it will know that, and it won't bug me again. It's the same way when you have an intern, the first couple of months, it's hard, but after that, they they're getting better. Now imagine a lifelong intern that's always with you, always becoming better and better. Now, open source is going to play a very big role, and we're seeing that more and more. Because when we look at an industrial model versus open source model, there's around a 6-month lag, 6 to 8 months, and that lag is getting shorter and shorter. The capabilities of open source models are becoming extremely powerful. Okay. And this is not just our own opinion, but even last year there was a leak from a Google internal analysis document emphasizing that them or even OpenAI are not really have the protection they think because they have these very large models themselves. The open source community is moving on and going to catch up. Now, this is all good and great, but when you look at how we're developing this software today, the best way I can think about it is exactly we are in the punch card era. So the old days, we used to develop software by taking punch cards, putting them to the mainframe. Then we evolved, we had text editors, then we had IDEs, then we have platforms. The reality when it comes to the way we're developing this type of software today is pretty much we're just a bit better than a than one punch card, but even worse than a text editor. There's a lot of problems of how we develop software. It's not how grown-ups basically develop software. We have years and years of experience on how to develop real software, and this is not happening today. Okay. Now, the companies that are able to do that are able to produce these type of systems at an extremely rapid speed. As you can see from Microsoft highlighting that, people are wondering how come we can produce so much so fast and so many different platforms and so many different business domains is because we have built the right platform to work on that. And this is as well. So this is something as well coming from Sequoia. So not only Microsoft. So Sequoia went in and talked to around 35 of their companies, either ones that have long been were startups many years ago, current startups. And what we're recognizing is it's much more beyond the foundational model APIs. There's a lot of push when it comes to the whole compute. How to actually get the compute users and the reusability and efficiency of the compute is becoming a very big issue, okay? As well, issues about governance frameworks, trustworthiness of that, especially as well in the the regulated industries. And there's really more and more this need that everybody's recognizing. There's a very strong need to a life cycle engineering platform that actually is focusing on development, governance, and operation, in addition as well to a distributed computing, programming model to work on that. So the key point here is, there's an urgent need for this lifecycle software engineering and governance platform that considers AIware, software makers, and the combined power of open source and corporate foundational models. Now, the last part here, I want to talk very briefly about the AIware itself, the compute. So what Satya Nadella is recognizing, saying the type of workloads we're seeing that these computes is putting on our infrastructure in Azure is something that we have never seen in the last 30+ years. Okay. And two things have happened. First is you can no longer run these things on a single machine, even if you have domain-specific hardware. So even if you have accelerators, you cannot run them on a single compute node. Okay, even if it has multiple cards, because either the compute nodes are too high, the compute requirements are too high, or the data requirements are too high. Okay? Things like Kubernetes, traditional HPC schedulers are not really designed to share accelerators. Accelerators have a lot more state in them. That's one. Second, accelerators' speed is much more different. Today, the way we work is the fastest CPU and the slowest CPU available. The differential in speed is not that high. And even when we look around, when you look at all the big players in this, the size of the clusters that they operate are even larger than national clusters. Okay? So more and more, there's a need for something that will actually enable you to manage these clusters, because you cannot, for every team, to actually have your own clusters. Okay? Now, one of the cool things about this is we're actually seeing where the foundational model is becoming its own layer. And that layer will enable us now, instead of when we want to migrate, we have to worry too much about migrating GPU to NPU or GPU to TPU. If you migrate the foundational model itself, then you will actually get for free everything coming at the top. So really now, you just migrate the bottom layer and everything comes on the top. I want to end this by focusing one thing is, bigger is not always better. So really need to recognize that don't go, remind you again, it's not about the size, it's actually about how to actually engineer this correctly, okay? So, really focusing on efficiency and the effortless, accelerated computing is a big vision going forward. Now, with all of this, why are we here today? So I hope at the end of the day you realize that to do this, we need to bring some of the smartest people around. So the reason you're here, you're one of the smart ones, okay? So if you didn't come here, you're not a smart one, okay? So we wanted to bring them all together, and today, we brought in 99 participants coming in from 63 companies. So 63, there's 63 of you that are coming from industry, okay? 12 countries, 4 continents. Okay? Now, this is part of a thing that we have started, last year. So last year in Mexico, we brought in 108 attendees. Half of it was from, around half of it was from industry, and the other half was from academia. This time we actually have 2/3 from industry and 1/3 from academia. I really want to emphasize, very important to have that discussion between industry and academia, especially in this domain. Okay. For the vision meeting we had, we actually created a report that really talks about what people have highlighted. That report is going to be up on archive later this week. If you want, I can actually share it with you as well. And as well, earlier this week, we brought in some of the world experts, academics, and some of the industrial folks as well, and we were in Shonan. So NII, had invited us to work in this Shonan kind of facilities out of nowhere. Everybody was locked in for 3 days, really trying to figure out what's the future of software engineering and how foundational models are work on that. On my side, my team, we're really trying to rethink what are the top 10 challenges when it comes to develop these type of software systems and how we can develop the next GitHub 2.0 or we think 4.0 for these type of systems. What are the challenges around them? Okay. In addition to that as well, we're recognizing that this idea of serverless computing, which is only CPU based, is no longer going to work. Okay. We need to think of this idea of fusion acceleration. So you need to think of accelerated computing. So this is a lot of clusters. It's a lot of accelerators and clusters. We need to think of data-oriented programming, and as well, the importance of intent and semantics. One of the biggest problems we've had today is we believe so much that compilers can read developers' minds. The reality is compilers are not magicians, okay? So it's very important that we have the intent of developers relate better to the systems, and we figure out how to use these type of software in a more efficient way, okay? I want to emphasize, our thank you for all our supporters for all the different events we've been having. Okay, so these are all our supporters for this event and as well for the Shonan. So NNI was actually funded, was one of the key supporters for the Shonan event. Okay. Now I'm here, I'm just one of many people that are working on this, right? So we actually have a full steering committee that has experts from around the world, from different companies that are working on this, and really trying to understand what is the future of software engineering, especially around foundational model, and what exactly it means to develop even software in this new world, okay? There are follow-up events as well. So later in the summer, there's an event actually in Canada. Professor Futz and Professor Jenny are actually here as well in the crowd. And I want to emphasize, there's many of the folks on the steering committee that are actually here. So please reach out to them. We're happy to get your feedback and see what we think we should do next. And as well, there's an international conference, the AIware conference. So if you look at your back, at the back of it, actually, that's the AIware conference. Now, I'm going to end up by saying you are the program. So today, there's many leaders here in the industry and academia are going to be talking, but we actually asked them to talk less and to have more panels at the end of every session. So do ask questions. The questions don't have to be on their specific topic, their presentation, but it could be on the general topic. And finally, speak up. Otherwise, you are stuck with the plan. Okay? So yeah, so that's everything I had. So thank you.